All right, the last video in this series is all about the hydrolysis of salts. And this is looking at what happens during an acid-base neutralization reaction. We obviously know that we have an acid and we have a base that is going to combine. And depending on whether the acid is strong or weak and the base is strong or weak, the resulting salt will also have a solution that is either acidic, basic, or neutral. All right, so the anion of the acid, so I always remember that with the AA, the anion of the acid and the cation of the base form the salt product. All right, so in general, we have the HA. This is your general term for an acid, okay? And we have the XOH, so you have your general term for the base, where the outsides and the insides are going to come together in that double replacement reaction that we've gone over so many times to make water and to make the salt, okay? So when it comes to the salt, remember, salt is a general term. It is not going to be just NaCl, okay? It is going to be any ionic compound, right? And those ionic compounds are going to provide us with information on what type of solution we have. Okay, so these are the criteria. Okay, so if you have a strong acid and a strong base, they will make a neutral salt. So what are the strong acids? There are 6 that you had to know: HCl, HBr, HI, that's going down your halogens in column 17. And then you know nitric, sulfuric. The one that might give people a little trouble is remembering perchloric, HClO4. Okay, your strong bases are going to be your group 1 and group 2 hydroxides. Okay, your alkali metals and your alkali earths. Okay, there with your hydroxides, they're good to go. Okay, then if you have a strong acid but a weak base, you are going to make an acidic salt because your acids are going to decompose and dissociate more, break up into solutions more than the base will. So there will be a more overpowering acidic solution. So you will definitely see what is an acid. So what are the weak bases? That's everything else that's going to accept your hydrogen ion. So if you have a stronger acid, it's going to be acidic. If you have a weak acid and a strong base, okay, then it's going to yield a basic solution. So basically, you are going to see that whoever is stronger here is going to produce the acid or the base. All right, so a weak acid is everything else that would donate the H+. That would be like your acetic acid, your hydrofluoric, any of your hypochloric or chloric acids, all of those. So let's see some examples of these. All right, so here is our salt. And remember, we are kind of going backwards here. All right, so if we have our HA and our XOF making H2O and our XA, this is the salt that is formed. So we're going to do kind of like a reverse synthesis in order to figure this out. All right, so let's remember the little things that we talked about. If we have an acid, the parent acid is going to be, well, we can't really see that on that screen. It's going to be an H plus bonded to the, that's right, anion. The acids get the anion, which is going to be the negative charge. Li makes a 1 plus, F makes a 1 minus. Oh, hey, look, there's ions again. It's almost like there's a pattern in everything we do. So we end up getting H plus and F minus, which we crisscross and we get HF. HF is not one of the 6 strong acids. This is our weak acid. Okay, so what do we get on the basic side? Okay, the base is going to get the cation from the reaction. So that is Li plus, and then we have OH minus. LiOH, lithium hydroxide. Take a look at my periodic table. Lithium is in column 1. This is the strong base. So what do I get with a weak acid and a strong base? I get a basic solution. Okay, the base is going to dissociate more. I'm going to have more hydroxides than I am going to have hydrogens in there. This might only dissociate like 5%, whereas this is going to be 100% dissociation. Okay, so let's take a look at the other one. We have RBI. RB is a 1 plus, I is a 1 minus. Okay, so the anion, I minus, goes here. And then I have H plus, I minus. This is hydroiodic acid. Hey, that's one of my strong acids I needed to know. Yay. And then what do I have on the basic side? Oh my gosh, it's so basic. So I have Rb plus and I have hydroxide as my base. So that's rubidium hydroxide. Take a look on my periodic table. Rubidium is in column 1. This is a strong base as well. So what do I get? If I have a strong acid and a strong base, they are equally going to cancel each other out, and I'm going to get a neutral solution. Okay, and lastly, what about aluminum nitrate? If aluminum nitrate is formed, remember, aluminum is a 3 plus, nitrate is an O3 minus, my anion is the acid, so that is NO3 minus, H plus makes it an acid, that is HNO3. HNO3 is nitric acid, that's one of my strong acids, so strong. And then I have Al3 plus and my hydroxide. Aluminum is in column 13. It is not in column 1 or 2. This is my weak base. So if I have a strong acid and a weak little base, this is going to give me an acidic solution. So if you haven't learned your ions, this is definitely going to be helpful because you need to know that these different ions make up these different salts, and working backwards you can figure out what type of resulting solution you have. And when you start taking AP Chem, you're going to figure out how to figure out the Ka value and the Kb value in order to figure out, exactly what the pH would be most likely. Okay, so that is our hydrolysis of salts. Thanks so much. Bye-bye.